Hello, my friend Colin here from Sonic Scholar, and today we're talking about Regex. A lot of people think Regex is scary, and indeed, if you don't know what you're looking at, it is kind of scary. But today we're going to unpack all that and demystify it. Honestly, it's one of the best tools to have in your arsenal when you're in a pinch and you need to parse some data or match some patterns. And understanding how to build Regex and put it together is an incredible resource to have in your back pocket as a software engineer. So before we get started, remember, I've got the cheat sheet here. Download that if you haven't already. The whole back page has the whole Regex, all the patterns, usage and matching and so on and so forth that you'll be able to refer to at any time, as well as the source code. You can get that in the link in the description or go to www.sonicscholar.com/string theory. Right now we're going to get into our Regex demo, which is running. So let's go check that. All right, popping into this example here. So if you recall in the last video, we looked at this pattern here, the string that's the quick brown fox jumps over the lazy dog. And we had this mystic Regex mysterious pattern that grabbed us all of the 3-letter words. You'll notice there's a number 3 in there that probably has something to do with it. But we're going to unpack that here in a little bit. Just real quickly, looking at that code again, run it through regex.matches, input string, and then the pattern. And then I've got this match collection debug string that's essentially just a little handy thing. I took the link from the last video and made it so that I get this nicely formatted string anytime I have a collection of matches. So if I pop back out and write that out, I can see that the match was the at index 0, fox at 16, the lowercase the at 31, and dog at index 40. Okay, so now let's unpack what's going on here. Well, in this \b\w3, we start at the \b. That is a word boundary. It's an anchor. And that's just saying make the pattern start at a word boundary. So anything that's, not a character. The \w, and these are case sensitive, by the way. So the lowercase w means match any word character. That's going to be upper or lowercase letters, any digit 0 through 9, and underscores. And then the 3 means take exactly 3 of what was previous. So there's 3 \w, so 3 word characters. Anything that matches one of these things, take 3 of them exactly. And the pattern must end at another word boundary, and that's important because if we don't have that, then we end up getting like QUI of quick or BRO of brown. So this whole pattern is surrounded by word boundaries so that we are only getting the 3-letter words. You might ask, do we really need to do Regex for something like that? I want to look at the string.split method, right? So remember how we use the string split on a white space and we get this nice string array. Again, I just have this little helper method here. It's yours if you want it. The source code's there. Just using some link to get a nicely formatted debug string of an array. And so what we have is the split method with the space character, and we get all 9 strings out of it. Well, we can use the same thing in Regex, but this time notice our pattern is the \s. So we're just going to split on any white space character. This is cool because there might be, well, we'll see in a second here. The @ sign preceding the double quotes just means a string verbatim. So there's less characters that you have to escape. So take the quick brown fox, split on the \s character. And again, I get that same array, same elements, same spelling, same number, nothing too crazy. In fact, you might say the string.split was actually easier to use than the Regex. But what if we want to split on a pattern that isn't a single character, right? what if we had a string that's a little bit more complex? So here I've got the quick brown fox, and I've complexified it a little bit. You can see there's tabs, there's like new lines, there's all kinds of shenanigans going on here, right? I've got a hyphen in here, a tab, spaces, new line, right? And I've got a colon. So what if we say I want to split on anything that's not a word character? Recall, a word character is A through Z, uppercase, lowercase, digit, or underscore. So that's all this white space. That should be all of these the hyphens, the period here, and I'm using uppercase W, which is the negation. This is just the opposite of the lowercase w. And okay, so we got something that seems kind of useful. There's a lot more strings in that array. We got a lot of empties. So it's kind of like in our string manipulation video, we might think to use something like a remove empty entries option. Well, we don't have that with regex, but a very simple link filter, we can just use the where and take for each string in that regex we only want the ones that are not null or empty, and that will get rid of all the empty entries just the same. So not too bad. And look, there we go. There's our size 9 string array with all of the methods. Now that just became quite a bit more powerful, I think you'd have to admit, right? Once this string was a little bit more complex, little regex pattern, again, this is not so bad. And we were able to split up all the tokens or all the words in that string with ease. Okay, we'll look at some other examples now. Here I've got some weather data that I generated with the help of ChatGPT that will be interesting for our purposes here. So here's all the weather data. We've got, looks like January 1st, 2nd, all the way through the 7th of 2022. And various parameters of weather from precipitation to wind speed. Well, we could definitely make a sophisticated parser. You know, we could split all of this on commas and get rid of white spaces and the like. But with regex, we're going to be able to do some pretty powerful things with not a whole lot of code. So what I want to demo now is using regex to calculate two things. We're going to add up all of the cumulative rainfall from these 7 days, as well as find the average, and we'll have a link to help us as well. And so what we're going to do here is we have this pattern. Oh my gosh. Oh, it's terrifying. It's terrifying, right? Well, just break it apart. What we want to find all of these precipitation values, and notice they're in different formats, right? It could have a digit, then a dot, and then another digit. It might not have a leading digit. It could just start with a dot. You know, they all end with the IN afterwards. You know, or it could just be a plain old digit with no dots. So here's what we want to do. The first digit is optional. So what we're going to say is \D. That's a digit, and there could be 0 or more of them, meaning it's optional. Or, you know, say there was 11 inches of rain, right? It could handle multiple digits as well. Then we want to match the dot character. Now the dot character in a regex pattern is a wildcard, so we have to escape it with the \. And then we want to say, well, that's optional too, right? Because, you know, you could have something like this where it's just 0 inches, or maybe it's 1 inch. And so there's going to be either 0 or 1 decimals as well. And so that's what this question mark is. The question mark says take the previous pattern, in this case it's the literal dot, and check for 0 or 1 dots that in that pattern. And finally, we're going to have 1 or more digits, right? So once we get past the dot, whether it's there or not, there could be, here's a case where there's 2 digits, here's a case where there's 1, here's a case where there was no leading digit or no dot, but there's, you know, 1 character. So there's always going to be 1 digit. the number has to have a digit in it, so otherwise it wouldn't be a number. And then we've got this thing here, which is called a positive look ahead. This is almost like an anchor, sort of like that word boundary, but it's basically going to say look for the pattern IN, just literally the word in for inches, and make sure that that comes right after that last digit. But we're not going to include it in the match because we don't want to pull like the word in into a number parser, but we want to differentiate this decimal number from potentially any of these other decimal numbers that have other characters coming after them. Fahrenheit, for the highs, or, even these integer numbers for the wind speeds. This is going to say only get us the numbers with IN following them. Okay, so that was a little bit of a, more complex breakdown, but again, they're just Lego building blocks. You understand how to work with them. And then what we can do is, I want to show you something. Regex tester.com. I should change this in the code. If we look at regextester.com, we have, I've got some strings here, and just copy it right in. And then right in this regular expression, I can actually write stuff that will in real time highlight what I'm looking for. So if I wanted to test this pattern out, let me come back here and grab this, paste it in. I can see, oh yeah, that matches, right? And I can play with the samples down here. Like there's 5, that works. 5 dot something. Okay, yeah, that didn't match because it's expecting another digit there. As soon as I add one in, it's happy again. So this is awesome. And then it also has the cheat sheet right here as well. Super useful for just debugging and building regex in real time. Now that you know how to do that, we'll just keep chugging along here. So I've got this pattern. There you can see it again. And now we're going to run the matches. And this is the cool part, is I can check out, make sure all my matches are correct by hovering over that variable, and I can see, yep, 0.5, 250. All that stuff looks good. 0, it ends in 1. So really, these are just strings at this point. And now I want to parse them all into an array of doubles. So with only 2 lines of link, again, super powerful, love link. For each match, that's what this M is. I can name this whatever I want. I'm just going to say parse the string value, and then that's going to return a double, and then just arrayify the whole thing. Now I've got my array of doubles. Boom. Can use the sum extension method that works for all things link, enumerable of numbers, and I can take an average, and then again I'm applying my string formatting stuff that we talked in a couple videos ago to print out a very nice message about what the average precipitation was per day. In this case it was 0.57. We don't care about all the numbers to the right because, who cares about that? So that is pretty nifty. I think you've got to agree. So again, I just wanted to wet the whistle on what's possible with regex. Super powerful stuff. And again, if you want to learn more, check out this cheat sheet. I go through all the patterns, and there's an example for basically everyone in there. So it's yours. Just go grab it. What are you waiting for? Go ahead and get that, and then all the source code's there for you too. And that is going to bring this string theory series to a close. We covered a lot in a short amount of time, but again, all that stuff's in the cheat sheet. So I hope this was helpful. Being able to work with text and wield it around is one of the things that will make you a master developer. So I'm glad you stuck with this playlist. Thanks for watching. Hit the like and the subscribe button if you found this series or content like this helpful. And I will see you in another video real soon.